Hello, Algebra 1 again. We are doing a very special lesson today on identifying number systems. This is really cool because this is the first kind of math theory and probably the only math theory you're going to do. But when you're all done with this, you should be able to identify different number systems and which numbers belong in that. Believe it or not, this will be a reoccurring theme that's going to come up throughout the year, so you need to know these. Um, Specifically one in particular. So go ahead and turn to page, I believe it's 15 in your book. I see you can see it's 13 on mine. And we're going to look at this very, very cool picture. So this is a really awesome picture that kind of tells you how these number systems work. You have natural numbers, which are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All of those numbers that keep going, but you do not have 0. 0 is not a natural number. So the whole numbers have 0 and all of these natural numbers. I thought that was pretty cool, the way that's laid out. The integers have all of the whole numbers, natural numbers, and they also include negative numbers. So the integers have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, blah, 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 forever. And you have negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, blah, 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 forever and ever and ever. But you don't have any fractions and decimals yet. The rational numbers is any number that can be written as a fraction. So 9 halves, negative 9 halves, that's a fraction. Doesn't matter if it's positive or negative. 7.12 repeating, that can be turned into a fraction. 11.23, that can be turned into a fraction, and 3/4 is already a fraction. So it has all of the integers, all the whole numbers, all the natural numbers included. Now, there's one more that we'll talk about, but we'll get to that one last. So the most important vocab that you need in this is what we call a subset. So a subset. Okay, we're not going to talk too much about sets, but there's sets of numbers. So a subset is like the natural numbers. It is a smaller piece of the whole. Okay, so the natural numbers are 1, 2, 3. The whole numbers have 1, 2, 3, 4, 5, 6, 7, but the natural numbers do not have 0. Okay, it's kind of a weird thing. So we're going to start with natural numbers are a subset of the whole numbers, and the whole numbers are a subset of the, well, let's look, integers. So the most important one, if you can get anything out of this, is integers. You need to know what integers are. The integers are a subset of the rational numbers. I was going to look back up, but I already know the answer. Okay, so you see how it kind of works its way up? There's kind of an idea of subset. So natural numbers, remember those are a subset of the whole numbers, and this is denoted with this n. But it's like a bold n, so they draw this little line on it, and it makes it look like it's bold. You'll see it on the bottom of this page. So examples of natural numbers, 1, 2, 3, 4, and it goes on forever. So more examples would be like 570. Okay, there's no fractions or decimals, it's just full values without a fraction and decimal. Another one would be 7, 9, 8, 0, 5. There's no decimal, we're good. There's no fraction, we're good. Whole numbers, usually denoted with this capital W with the little line. Not talked about very often. They still have all of those. So they still have 1, 2, 3, 4. Remember we talked about like the natural numbers are a subset. So we have all of those. We have that 570 in here. We still have the 7, 9, 8, 0, 5, 0. But we also have 0. Natural numbers do not have 0. Whole numbers have 0. You can see. So the only difference is that whole numbers have 0. Okay, so when you guys say whole numbers in class, what you guys mean as whole is not a fraction or a decimal, but really you have to be careful. Integers are denoted with a capital Z. Don't ask me why it's a capital Z, I can't tell you, but that's how it is. So examples of integers, we have all of the ones that we named before, 1, 2, 3, dot, 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 4, 5, 6, 7, that's 790, all of those numbers, they go on forever, but they also have -1, -2, -3, -4, and it goes forever in that negative direction too. So we have all of those numbers, we have 0, it's great. The rational numbers, again, don't be mad at me, these are just the symbols, I'm just the messenger, don't shoot the messenger. We have Q. Now, this is how they'll write it like this. That's a bold Q to some people. I don't know why, that's how college professors write it, but that's the symbol you're going to see. You can see it down here. It looks different down here because it's harder to write it. I don't know. But that's how most professors write it. So again, we have the 0, 1, 2, 3, 1, 2, 3, there we go. We also have the -1, -2, -500, all of those numbers, remember? But we also have the fractions. So we have 1/2, we got 790 divided by 563, like anything that's written as a fraction or decimal. Well, not every decimal is a rational number, but most of our decimals will be rational. Like if you have a decimal that goes on forever and doesn't repeat, that's not rational. Okay, don't worry too much about that. Just keep in mind the difference between integers and rational numbers. So remember, integers are the main thing I need you to get out of this. You need to know what integers are. Positive numbers, negative numbers, there's no fractions or decimals. If there was a second thing I could get you to remember for the rest of the year, it would be rational numbers. Okay, it has all the integers, but it also has the fractions and non-infinite decimals, so like 0.5. If the decimal ends, so like 0.7931, it ended, that's fine, but also the repeating decimals like 0.13, that repeats, or 0.333, you know how it repeats? If it repeats, it's also rational. And finally, we have real numbers. Here's the symbol for real numbers. It's a bold R. Okay, that's how they write the bold R. Again, don't get mad. These are every number that we know. Okay, there's a couple numbers that are not real, or there's a lot of numbers that aren't real, but we're not going to talk about those in this class, so don't worry about it. So this could have the decimals that go on forever, like 8, 7, 6, 7, 9, 3. Okay, there's no pattern, they go on forever. That is a real number, along with everything we've already talked about. Everything you know is a real number that we talked about. Also, pi. You know how pi is a number that goes on the 3.1415997. Okay, I don't know all the numbers of pi, but it goes on forever and there's no repetition or any pattern. It just keeps going and going and going. That is a real number. It's not rational because it keeps going on forever with those decimal places, but it's a real number. So here's an example. We have the number 0. Which number set is it a part of? Is it part of the natural numbers? No, that one does not include 0, so it's not. Is it part of the integers, z? It is, yes. So if it's part of the integers, it also has to be a part of the rational numbers, because you could write it as a fraction, right? 0 over 1. Is it a part of the real numbers? Yes, the real numbers are all the numbers we know. Back here, which number set is this a part of? Is 0.5 a natural number? No, it's got a decimal. Is it an integer? No, it's got a decimal. Is it a rational number? Yes, we can write it as a fraction. In fact, we could write it as a half. Okay, the decimal ends, so we know it's going to be rational. If it's rational number, we know it also has to be a real number. Okay, real numbers, again, everything we already know. That's it. It's going to be a little confusing, I think, but you're going to do just great. Okay, watch this again. Anything else again? Bye.